the infrastructure to create a secure posture from the ground up. So that's essentially our core belief, and we believe the hypervisor is a great place to actually enable and deliver some security value, not just treat it as another piece of infrastructure to secure, but instead actually use it as a tool to create a more secure posture. So one point to note is kind of where we spend the vast majority of the time trying to deal with the attack chain. And this is a simplified attack chain. We use this more for large-scale events. Before joining VMware, I spent a number of years at a company called RSA Security. And RSA was obviously much deeper into the security analytics and security threat game. And while we were there, we actually did a study. We wanted to figure out why people were being so ineffective in actually solving a real security challenge, right? So clearly budgets were going up, people were spending more money on security. We were a company ourselves that had no lack of security talent or no lack of security budget, yet we were subject to our own breach. The RSA token seed database was breached in 2012, if any of you remember that. So we really wanted to get down to the nitty-gritty here as to why this kept happening, given the fact that budgets kept going up. And what we found, we actually used McKinsey to do a full-scale study in the market, and what we found was that 70 to 80% of all security investment, this includes the time, the effort, the products you buy, the people that you deploy, we're going towards stopping infiltration. And essentially what that would be is typical common infiltration points, which would be your end user assets or the perimeter of the data center. And very little sort of investment was going towards the later stages of the attack chain, either towards trying to do things relative to detecting attacks. You know, you just heard a whole presentation talking about how we can detect things earlier in the life cycle and how you can reduce dwell time. We had our own product called RSA Net Witness, which sort of had that same mindset, which was how can we get better insight into finding things and detecting things earlier in the advanced attack lifecycle. And almost nothing was going towards actually appropriately responding to those events. So when events were discovered, like what we had inside of the RSA breach, it was virtual chaos trying to mitigate that event in real time. At some point we got to the point of where we literally just shut off all outbound network communication across all of EMC. RSA is owned by EMC, which is now owned by Dell. And that's 65,000 employees that you essentially cut off from the internet completely because they had no other way of understanding what the attacker was trying to do. So the response mechanisms were completely out of whack. So fundamentally what we really, and we did a post-mortem, really nailed that down to is that there really wasn't a good understanding from our security team about the infrastructure they were trying to secure themselves. That's the first problem. Second problem is the environment was way too rife and sort of available for lateral movement and lacking some basic security hygiene inside the infrastructure to just purely enable or disable attackers from actually doing what they were trying to do. And again, you hear it over and over and over again, apply patches, create more secure hygiene, create a better segmentation and segmented environment. These things would have significantly helped in our case, right? They would have significantly reduced the burden of the breach. The attack was a 0 day at the start, but it wouldn't have been able to propagate itself to a secure ID token database if we had done our job properly and segmented the network appropriately. So that's fundamentally what we're solving on a day-to-day basis with our products at VMware. You know, we're helping to solve and create some more security hygiene focused on the middle area of the attack chain. We're talking about assets that are meant to protect your data center, using our virtual infrastructure as a tool in protecting the data center itself, which is not typically the infiltration point, right? We're talking about east-west traffic flows, we're talking about data center assets, creating a more secure posture in those machines. So, you know, why is this a difficult proposition, right? So why not everyone just focus on the middle area of the attack chain, propagation, extraction, and sort of call it a day? Well, fundamentally, again, simple picture, but my belief comes down to when you're dealing with internal traffic, east-west traffic flows, which makes up, in most cases, you know, 70 or 80%, if not more, of the traffic that you're going to see and evaluate inside of a data center, especially a modern kind of software-defined data center. It kind of fits into this rough bucket, which is you can classify some traffic as known good, you know, things that you know should be happening and know that should be there, but that's a very, very small sliver. Because most people just truly don't understand their environment. I just came from, you know, 5 or 6 major oil and gas companies in Houston. I can't tell you, with bar none, all of them, their first problem, they said they had no idea how their applications acted inside of the network. They just had no clue. And that basic, you know, level of lack of understanding of even knowing what's good behavior is kind of step one. You have to be able to classify and know good behavior. There's some things you can filter out as known bad, but that's all the signature-based stuff. That's like, hey, I know a bad IP address when I see it. I know a bad hash when I see it. When I get those indicators, I can pop them up and I can see them really fast. again, if you have a good attacker who knows what they're doing, they're likely not at that point, especially later in the attack chain, they're going to be using known bad signatures. They're not going to make your life that easy. The rest of the stuff gets dumped into this giant gray area of unknown behavior, right? And, unfortunately, there's not a whole lot of answers in the security market to really deal with that unknown behavior. Again, going back to the RSA case, we were selling a product that essentially helped you manage some of that gray area. At the end of the day, not to disparage my old colleagues, but all we did was just dump a bunch of data into a database somewhere and have you look it up and figure it out yourself. And that was the answer, right? Which is still the answer, unfortunately, in most SIM use cases, right? So what you see right now is some people taking that information, creating some rule-based analytics on it, creating some dashboards inside of Splunk or some other SIM tool, which again works for some things, but it's not going to be a panacea for things that are going to be serious events. By far, the best thing you can possibly do, hire a bunch of good analysts, people who really know what they're doing, know how to do threat hunting, know how to dig through information, and know how to triage this data when they see it. Unfortunately, that works for like the 0.05% of companies that are out there, right? It may work for some people in the financial sector. It may work for some other people in the high-end tech sector. But at the end of the day, even for a company like VMware, virtually impossible to hire really good security operations center analysts, right? In the Valley, where we deal with, we're competing with Google, Facebook, Uber is on our own campus. These are companies that have to deal with securing services day in and day out. It's virtually impossible, if you talk to our CISO, to find a good security analyst to join even a large public company like VMware, right? So this is harder and harder. This is just a harder and harder thing to do. And then lately what you've seen is some techniques relative to machine learning. I see a lot of companies on a daily basis come in and pitch VMware about, hey, take a bunch of your log data, run some magical machine learning algorithm, and we're going to have no false positives, and it's all good. Now, I think there's a lot of potential in those directions, and there's a lot of things that you can possibly do by running some targeted machine learning analytics on things like user behavior analysis or some other particular traffic patterns. But at the end of the day, right, a lot of those are still driven off known attack patterns. They're driven off things that you have recognized and seen before in the past. So they're not going to be a panacea, at least in my mind. They'll help advance the ball a little bit, but they're not going to fix everything. So this is kind of where you're at, and this, I think, unfortunately, is where most people are sitting inside their data center. Again, simplistic picture, but this is what we're essentially trying to do, what we're trying to solve and fix for most customers. And essentially what we're trying to do to solve and fix this is, what can we do to reduce this gray area, right? What can we do to better understand, classify, normalize your environment in the first place, build in some security intelligence from the ground up by knowing exactly the way the application should behave from the ground up, and then apply the appropriate security controls around that to enforce a least privileged environment. And that's kind of more or less the philosophy, right? Which is really understand your data center applications, understand the way they behave, understand what they should be doing. Then you can start securing them. You can start aligning your controls appropriately around those applications, and you can start enforcing a least privilege posture and a least privilege principle. Which again, if you look at any real attack pattern, at some point it's going to deviate from the normal state of behavior of that machine. In which case, you don't necessarily have to be on top of the latest attack techniques, and you don't have to have a ton of reverse engineers to figure out that something is looking anomalous and something is looking wrong when you enforce a least privilege posture, right? So it's essentially comes down to enforcing good versus chasing bad as the primary mechanism. And most people don't necessarily argue that from a security principle is wrong. Typically, you'll get people who say, operationally, that's extremely difficult to deploy. I can never maintain a whitelisted least privilege posture. It's too operationally difficult, but it's really hard to argue from a security perspective that this could be a more effective model than chasing bad if you just look at the way in which attacks typically propagate through the environment. So how do we go about enforcing good behavior, right? Our primary mechanism in market today, which is deployed very widely across the financial sector, very widely across most sectors, is something called Vmware Nsx, which is the capability of doing, essentially software-based networking, virtual networking. And the functionality here is using your existing ESX hypervisors that are sitting out in your environment. What we do is we embed some core functionality within those hypervisors to create a network service chain. Things like routing, switching, firewalling, and in the future, or now at least, we can start doing encryption inside of that service chain. So every single time a packet leaves from a virtual machine, it gets placed through this service chain, and the routing and switching policies are governed by a central entity, governed by the Nsx controller, and you can also start placing firewalling policies explicitly tied to the assets and the virtual machines that you're trying to protect directly in the hypervisor itself, right? So that's kind of the core, and again, I'm going over this quickly because we don't have a ton of time here. But that's kind of the core capability of NSX. Think of it as just taking some common network functions, like routing, switching, and firewalling, and embedding them into the hypervisor such that they can be more or less centrally governed. And you can start creating specific security policies and specific network and routing policies to create a more microsegmented environment. And the way in which this allows you to start creating least privilege is first at the network layer. So NSX has the ability to create least privilege in the network at a pure sort of routing and switching level, right? So you can have essentially the ability to have two virtual machines who might be sitting on the exact same host, physical host, or might be connected with the same physical wire, to not have the ability to communicate with one another at all, right? So you can cut off their ability to route traffic to that other virtual machine completely. So you can create a true, separated, isolated network using pure software-defined principles, so it doesn't have to be tied to the hardware at all. The other way in which we can do this is using the embedded distributed firewall that's inside of every single hypervisor where NSX is deployed. So if you wanted to have the ability for two virtual machines to communicate with one another, actually be able to route traffic to one another, but control it from a firewalling perspective, that's what NSX can also do. So you can start creating segmentation policies that are either hard boundaries, or you can start creating segmentation policies that are more soft boundaries that are enforced at the L4 firewall level. The other interesting thing about microsegmentation that we're seeing with a lot of customers is the fact that you can use the microsegmentation boundary. If you create this boundary around your application and you're appropriately segmenting that environment, and you're essentially walling off that application and kind of giving it its own little mini data center, is that it doesn't just act as a boundary point on the network. It can actually act as a place in which you apply security policy specifically for that application. What I mean by this is kind of tough to explain without a whiteboard, but one of the challenges that you typically see in large-scale networking environments that create security issues is that it's what we call the commingled policy problem, which is you tend to have these major jump points between one segment in the data center and another segment in the data center. And what I mean by that is you might have your DMZ, and then you have this large Uber firewall that's responsible for handling all the traffic that goes from the DMZ to your web layer, and then you have a web layer, and then you have a major Uber firewall sitting in between your web layer and your app layer, and then you might have something else sitting behind that to go into your databases. And that's in a good scenario, right? That's when you have a customer who's taken the time to do some level of segmentation, but they haven't necessarily completed a completely wide open network internally. The challenge with that is each one of those points, right, essentially has to commingle policy potentially across hundreds, if not 1,000 applications, all in one spot. Because it's the only thing governing the jump point between your DMZ and your web layer, or between your web layer and your app layer. So the security profile of any given app that's sitting in that segment is only as good as the most insecure application in that segment. Meaning that if you say one application comes to the security team and says, I need you to open up port 1433, I need to communicate over that port, that means that every single application has the potential of jumping across that firewall boundary using port 1433. So it's essentially creating this commingled policy issue. So you can't really harden a particular application very much when you're commingling policy across various apps. Which again was another issue that we ran into with the RSA environment, right? It wasn't that the secure ID application was necessarily insecure. It was, in fact, it was on a shared network that had some insecure policies associated with it. So what we can do with NSX is start using that segment boundary, the definition of that segment and the machines that make up that segment, and applying policies specifically to that boundary point. So you essentially have its own IPS system. It has its own next-gen firewall system with something like Palo Alto and the other partners that we use for next-gen firewalling. It has its own firewalling policies that are embedded inside of NSX directly, and it can have its own encryption policies, right, and how the data and the traffic should be encrypted. So it's kind of given its own little space to maintain a boundary point, and its own little space to maintain its own policy definition, which can be a very powerful mechanism. And again, a lot of this comes down to pure, basic, hygienic principles, right? The ability to just simply govern and manage policies inside the environment and create a better least privilege posture in the environment with standard controls that you already are using on a day-to-day basis. It's just operating them and using them in a better way and at scale. The second way that we can create least privilege is what we refer to as the data plane, which is really the ability to secure traffic as it hits the physical wire. All right, so one of the things that tends to give some people heartache when we talk about NSX and the idea that we're pulling networking decisions up into this logical entity, this software-defined entity, and no longer is tied to the physical hardware itself, is they say, well, I'm starting to lose control of the physical boundary. How do I know where the traffic is routing through, and how do I know who might be listening on the traffic and who might have plugged in something on a spam port and might be getting information off that way, especially when you start looking at going across stretch networks and potentially hitting the open internet or anything that might be less secure than your data center. This starts to become a heightened issue, right? So what we did is we announced a product called Distributed Network Encryption. And what that is essentially provides the ability to do point-to-point encryption tunneling, IPsec tunneling, for any two nodes inside of NSX without making any additional application changes. So you can essentially secure the physical wire and be assured that no one on the physical wire either has the ability to see unencrypted traffic or has the ability to manipulate or change the packets as they're going across, because we do an integrity check on either end. So you don't really have to worry that much about where the traffic is flowing on the physical wire, right? It becomes much more agnostic about where it goes in the physical wire. Think of it as the same way you would like to create a VPN tunnel or an SSL TLS tunnel for data that's flowing across the open internet. You don't really care or know where that data is flowing across the open internet. What you care about is the fact that it's encrypted along the way so that people who are sitting in the middle can't get access to it. So that's a very critical sort of least privilege posture that we deliver inside of NSX as well. And then the last piece of the puzzle is, what are we doing to deliver least privilege posture at the application level itself? So, I'm sure anyone can tell you, you can create network segmentation all you want, and you can create these boundaries in the network. What if there are vulnerable application components sitting inside of that endpoint? What if someone has a position inside the operating system? What if they're kicking off things directly inside of the app itself that might be using open, legitimate channels inside of the network? It's difficult to stop those types of things when you're only looking at network-based behaviors in a firewall. So that's why we launched the product called App Defense, which is essentially our ability to kind of peek into the virtual machine and start enforcing some things directly inside the virtual machine itself, such as a process whitelist inside the machine. We can enforce the way specific processes are allowed to touch the network, so create more policies around, essentially think of it as a process-based firewall. And then we can also see a lot of other events that we currently aren't doing anything with, but will over time, which is around the file events in that system, the user events in that system, and any other potential sort of manipulation that might be happening on the system itself. And again, this is because we have a position inside of the hypervisor that's seeing pretty much every single system call that happens from the machine itself. Right? You can't get around that when you're sitting inside the hypervisor as an intermediary point. I'll talk about this a little bit more in a second. So all of this, I think, put together allows us to sort of move away from this model of chasing malicious behavior, which again, I think even if you sort of took the approach, which I'm not necessarily a disbeliever of, but even if you took the approach to say, look, I'm always going to have to do something relative to chasing threats and hunting bad. I can't get away from that completely, which is fine. If you're in a fairly mature organization and you have the people and the ability to do that, 100% you should continue to hunt bad behavior. The problem is you wouldn't necessarily default to only hunting bad behavior, right? It's probably a bad idea, when you're trying to secure your house, to just put an alarm system on the house but not lock your doors or close the windows. So we always look at it as if you just only do hunting for malicious behavior, you're essentially always going to be in a situation where that's more expensive, less effective than if you first started by creating a least privileged environment and locking down the environment and enforcing good behavior. And then when you start to see things that are potentially going wrong, you can see those things and they come into focus very fast, and then you can deal with actually handling those particular malicious behaviors in a much more focused way, as opposed to just blindly hunting for everything. And this is not something that's just shared by our beliefs, right? This is something, this is a Gartner triangle that's probably difficult for you guys to see, but it essentially refers to what they refer to as cloud workload protection. What you should do to secure your data center workloads and your data center endpoints. And at the bottom end of this pyramid is what they call the foundational security elements. And this is where they have vulnerability management at the very bottom. Then they have network firewalling, segmentation, which we obviously are big believers in. And then there's system integrity and application control and whitelisting, and then exploit prevention, memory protection, all of which we deliver with App Defense. So it's really about rounding out this core workload protection, these foundational elements. And then obviously if you want to go apply things like host-based intrusion detection or EDR or other things on top of that environment, they would consider that additional protection strategies. Unfortunately, this is not the way most organizations work. I mean, day in, day out, talking to customers, generally speaking, most of them start at the very top end of this pyramid. The first thing that they deploy, and many times the only thing they deploy, is AV on their servers, which, you know, Gartner themselves say is the least effective control that you can have in the environment. And the reason for that is pretty simple. You know, by the time the attacker has gotten past all of these protections that you have in place, potentially at the perimeter, if they're tripping wires with a pure AV scan inside your data center, it's a really odd thing for that at that point to be caught by a signature-based AV system. You know, unless someone is sitting there like an end user inside of a server in the environment, surfing the internet and opening attachments, it's a really difficult thing to do to just blindly be caught by an AV system in a server-based environment, right? Because at that point, the attacker's probably using way more advanced techniques because they've gotten past a whole lot of stuff. Okay, so I'll touch on quickly what are the interesting aspects of virtualization and why we are in a good position to do this, and then maybe talk about App Defense for 5 minutes and take some questions. So one of the big things that we look at when we think about, you know, why the virtual layer being a unique place to solve this problem, one of which is our ability to kind of get a better understanding and see what's happening in the application. And we do this across two vectors, right? The first vector is we pull in data from what we call intended state sources of information. One of the beauties about software-defined infrastructure, one of the reasons that VMware became very popular as a company, was the fact that you started to create the ability to configure your compute the same way you would configure anything else in a software-defined, agile, sort of on-demand way. Right? You had the ability to spin up a virtual machine, take down a virtual machine, manage that all through, you know, pure software-driven resources, as opposed to being tied to physical hardware devices and putting a new box to deploy a server. Obviously, this is getting faster and faster and faster as people use things like Docker, and you're able to provision and spin up new cloud instances very fast. But at the end of the day, any good software-defined modern data center has the ability to do automated provisioning and intended state of the environment to begin with. Network virtualization takes that same concept and brings it into the network, right? You want to be able to program the network in the same way that you want to be able to program the compute layer, which is essentially not have it tied to any of the physical hardware itself, but be tied to a software-driven policy set, right? So you can configure, change it, all of that can be done on demand. So at the end of the day, virtual infrastructure is on the receiving end of intended state. We're typically the ones that are told, here is the way I want you to set up this environment. I want you to create these 4 VMs with these particular OSs, and I want them to be connected on this virtual switch. And I want to have these firewall rules in place. All of which typically give us a pretty good idea of what applications you're looking to deploy. Many times people use tools like, we have a tool called Virtualized Automate, which helps blueprint these applications and push them out, you know, with a push of a button, publish the whole application in one. People use other tools like Puppet or Ansible or Jenkins or other configuration management tools, which are usually responsible for programming the environment. All of that we can grab and treat as intended state posture. Things that you're explicitly saying, I want the environment to work this way. Therefore, they become very authoritative pieces of information, such that if the environment deviates from that later on down the line, we have an issue. There's a problem. The second thing we can see is runtime state. So in order for, forget security, for the hypervisor to do its job on a regular basis, it has to be in the middle of every single system call that happens from that machine. Every time you touch the file system, every time you touch the network, every time you want a piece of CPU, anything, it has to be in the middle of that. That's its core primary job, is to deliver those resources to the VMs that are sitting above it. The same with virtual networking. Your primary responsibility is to process packets in and out of the machine. You have to be in the middle of every single packet coming and leaving the machine. So from a runtime state perspective, we're in a very unique position to actually see all this information and use it as a signal for security. Where typically you have other security products that have to bolt on or deploy agents or kind of tap into other NetFlow systems to see all this information or tap into spam ports. We have this unique position to get all this information naturally as part of the infrastructure. So combining these two things together, we can actually create a pretty good understanding of applications, right? And pretty good understanding of the way your apps should behave, which again gives us that ability to kind of shrink the gray area and apply policies appropriately. The second thing, which is probably one of the most important, is this notion of isolation. The idea that the hypervisor is an isolated control point. It's someplace where you can take a control that has to live outside of the guest, because you want to keep it isolated from the guest, which is usually where the attacker is. And you can stick it inside the hypervisor such that it's in its own, separate attack domain, but it's close enough to the guest that it can actually see into it, get all the context about it. So you have this perfect middle ground that you can place these security controls in that has enough context from the guest, but is still in a period of isolation, or a place of isolation. When we started App Defense, we called it Project Goldilocks, right? Because the concept was like the hypervisor is the Goldilocks zone for security. It's kind of sitting in this perfect middle spot between isolated hardware and the guest operating system. And then the last piece is automation. This is where, again, if you want to use automation as a tool on the back end, you can use that. With NSX, we can change the security policy around any machine with a simple API call, and that includes configuring the firewalling policies directly with NSX. It includes changing the routing and switching policies. It can include changing third-party endpoint and network configurations, and inserting third-party security controls like Palo Alto or Checkpoint or any of our other partners. All of this can be done in an instant. So that ability to use this automation and the software-defined data center principle as a tool can be very powerful as a remediation mechanism. So that's essentially what we did with App Defense, right? With App Defense, we said, look, we want to take this up a level. We want to get more distinct awareness of what's happening inside of the application itself and really see what's happening inside of the virtual machines. So we created a product that kind of lived across these three buckets. The first is which we use this unique position to understand application behavior, to sort of capture all this information and model your data center apps. So when you come into App Defense, everything is driven top-down by what application are you trying to protect or lock down, what are the appropriate behaviors, what are the members, the virtual machines that make up those apps, and here is how I can create policies to kind of enforce least privilege in those applications. The second piece is around detecting and seeing those events, right? And we use a combination of the hypervisor as well as a protected position in the guest to do that. And then the third is responding to events in the back end. So when you see things happen that are going wrong, what can I do about it? Can I block it immediately? Can I alert on it? Can I take some more complex actions that might require calling into ESX, maybe snapshotting a machine on demand, or calling into NSX and changing a security policy around a machine? So that's kind of the pillars of the system. And I'll touch on these things just for a minute each. I'll skip over this in the interest of time. So the first idea around capturing, essentially what we do with capturing intended state is, like I said before, we tap into these infrastructure configuration systems. So whenever we deploy App Defense, the first thing we ask is there a tool like Puppet, or is there a tool like Ansible, is there a tool like Jenkins, or something that can tell us about the environment to begin with? So after we've synced all the virtual machines from vCenter, we'll then go out and crawl these systems to see how we can classify those machines. So a workload, a machine at any given point in time, is either something that we call unassigned, I mean we don't know what role it lives in, or it's been assigned to state, either explicitly by the user or because the configuration management system has told us this is what application it belongs in. We did a really cool demo at VMworld, which I'm sure we can follow up with the link. We showed how Puppet Orchestrator configured, set up, without doing any work, basically an entire application topology. It told us specifically what virtual machines were there, what communication patterns we should expect, and what packages and binaries we should expect on the machine, all coming from Puppet. So that's the first thing we do, is we tap into these infrastructure config systems. Then we look at developer automation. So when we're pushing code with things like Jenkins or Maven on a regular basis, we typically ask developers at that point to inform us of expected flows inside of the traffic, right? And this is something that you normally see them do with manual security reviews. If any of you are responsible with sort of asking developers to go through manual reviews, typically they have to say, these are the ports I'm going to use, this is what I expect to be open, this is how I want to talk over the open internet. So what we do is, instead of having a manual security review process, we automate that and say, build that into your build script, and we'll collect that information and use it inside of App Defense. And the very last piece of the picture here is we run every piece of traffic that we see at runtime, if we don't get anything up front, through some lightweight algorithms. One that says, hey, is this a reputable piece of software? Does it come from a known good publisher? Is it known good hash? The last thing we do is we do a lightweight machine learning algorithm for commonality. So we check to see, is this something that we see very often? And whether we have explicitly seen it before, let's say we have 1,000 SQL Server databases in our overall tenant base, we'll say we've seen this 99.9% of the time in SQL Server databases, or is it close enough to the behavior that we can verify it on your behalf? And all of that gets stamped down to what we call a virtual machine manifest. And that virtual machine manifest is basically a collection of the behaviors we expect to see on the device. This is a screenshot. I'm not going to be able to get into this, but that's basically a screenshot of how the manifest looks and how you verify behaviors. And then the interesting piece here is how we then start to do detection. So what we do with the hypervisor is we expect the hypervisor to actually create integrity in the system. So the hypervisor is really good at maintaining an integrity state. So what we did with this is we basically tricked the virtual machine monitor, which is the component of the hypervisor responsible for delivering resources to the guest. We said, look, keep a certain percentage of resource available to us as protected memory, a protected memory region that we can place components into the guest, like the manifest, such that if anyone tampers with it, we get immediate notification. So it's kind of like a tamper evidence seal on a bottle. As soon as it's messed with, the hypervisor will trigger an alert. So we know that we're kind of living in this safe, protected zone. The other thing that we do with that capability is we put that watchdog on the operating system kernel. So we ensure that the operating system kernel itself is not manipulated at runtime. Think about that as sort of a TPM attestation happening at runtime after the machine is loaded and booted. And then once that's there, we start to monitor the behavior coming from user space. This is all your process behavior, your network behavior, your file system behavior, and your user behavior. So typical behaviors that you would see with an EDR type solution, that's kind of hooking events coming from the operating system. So the two of those things together start to be able to essentially monitor that behavior against the manifest. So anything that we see that violates the manifest, so it's essentially unexpected behavior, we can start triggering actions from that. And that's what gets us into the response. The simplest response is just to block the behavior if you just want to run in an app control mindset and just block. But more complex responses can call into the virtual infrastructure and kind of take a more advanced remediation. One common thing that we always talk about as an interesting use case is, let's say you wanted to do something like full packet capture in your data center for forensics, for forensic reasons. To do that across every single east-west traffic flow would be an impossible thing to keep up with. First of all, it'd be super expensive because you'd have to keep up all that storage. Second of all, who is looking through all that traffic and actually analyzing it? So with NSX, we can essentially do full packet capture on demand. We can say first use app defense to recognize this anomalous behavior, and then kick off full packet capture for a particular app only when I see anomalous behavior. So it becomes this sort of think of it as like ratcheting up the security profile of an app in response to an event. Same thing with encryption. You can start encrypting flows on demand. You can insert third parties on demand. All that can be done. And then another simple control that people use a lot is just snapshotting the machine. If you want to take a memory snapshot, that can be an on-demand event that occurs when we see an anomaly, and then you can look at it and get a forensic dump after the fact. So that's it. I think I'll give some time for questions, but this is deployed as a SaaS architecture today. We do have the capability of pulling that architecture down and running it purely on-premise, but it's meant to be that way, number one, so we can get collective sources of information at the security manager between all of our tenants, so it helps us in that commonality analysis. But it also allows us to run it seamlessly across workloads that are running in the cloud. So we have an initiative called VMware Cloud on AWS, which is essentially running VMware stack on top of AWS. So this allows us to basically have the same security controls in place for that infrastructure as we do for the on-premise workloads. And there's no hard requirement, just if anyone's interested, there's no hard requirement to run NSX to run app defense. It uses NSX, but it's not an ingrained piece of NSX. The only hard requirement is that you are running an ESX hypervisor. Today you have to be running ESX 6.5. So with that, I'll happily answer any questions.
One question.
Sure.
Nowadays the workloads become Dockerized, and so that most of the workloads in the common environment is based on Docker. So, you have been providing some application layer segmentation, but that doesn't cover this Dockerized.
Sure.
The workloads itself.
Sure.
So.
Sure. So Docker, I think, is a blessing and a curse a little bit, right? One thing that's good about Docker is that it's a shrunken compute instance, and it's typically an immutable compute instance. So when you look at trying to enforce a least privilege posture with Docker, you're actually in a much better state, because the smaller you make the compute instance, the more immutable it becomes. When you have a full-fledged virtual machine, and you have to handle operating system behavior and other things, it's difficult. So we always think Docker can enable this model very well. The challenge that we have is that, as in sitting inside the ESX environment and watching Docker, we have a level of indirection there, because you have ESX, and then you have the Docker host, and then you have all the Docker instances. So what we do to solve that is we partner with a security vendor called Aqua Security to basically handle native Docker environments. And we built in some pieces for what they call vSphere integrated containers, which is essentially our ability to run native containers on top of vSphere. So that's how we solve that use case. But it's we think the model works well for Docker. It's just a matter of getting a point of presence in the Docker host to see the specific instances that are running.
Because the Dockerized environment or any kind of net container environment will ruin your application provider that you mentioned. On the VMs, you try to profile and you try to segment, but if you run different kind of Docker machine there.
Yeah, there's a level of indirection there, I think, is your point, and that's true. So you have to have a position in the Docker host. You have to understand not just things at the hypervisor level, but in the Docker host itself, which is why we partner with Aqua. But once we have the information coming from the Docker host, the model works very nicely. You could enforce the least privilege model very nicely there. So it's, I think, a powerful use case, integrated use case. Obviously, we would prefer everyone to be running vSphere environments and not running Docker environments, but it does work nicely with Docker. We just have to partner to get there. Any other questions?
Can you talk about how the hypervisor should be secure, or how the security is implemented?
Yeah, so you're talking about actual host-based security from the ground up, like in the host itself.
On the host itself.
Yeah, on the host itself. So yeah, so there's a number of initiatives, like with 6.5, I don't know if you're using ESX 6.5 or earlier, but with 6.5 they launched a number of initiatives to secure the environment from the ground up. So clearly, like, Secure Boot was one of the biggest things that we did in ESX 6.5 that really enabled at least some trusted boot for the host itself, right? Because previously we didn't allow the use of trusted boot for the hypervisor all the way up the chain. So if you look at just using pure hardware attestation at the bottom end and ensuring that the host has not been manipulated or messed with, that's the first thing that I would always recommend, which is actually like even below the Gartner pyramid there's essentially doing hardware attestation and Secure Boot to ensure that the hosts are not manipulated or messed with. Beyond that, I think there's some interesting things that we're doing to maintain sort of I'll call it an immutable host infrastructure that's probably coming in ESX 6.7, which essentially means that the host configurations can't be changed. Right? You have the proper privileged identity management on the host. You can't install VIBs, like vSphere installation bundles on the host to manipulate them. So it sort of creates a lockdown least privileged host so that people can't mess with and configure the host itself. But the most important thing I would say to do on the host currently is to maintain some privileged user identity management, right? So we don't have a great, admittedly so, don't have a great user management model inside of the host or inside of vSphere. So a lot of customers will use something called High Trust to maintain some privileged identity layer on top of the ESX environment, which is always what we recommend if you want to maintain a really good secure posture in the host.
Yeah, that's right. Typically, we found a lot. Typically, when the virtual machine put it up, typically has a default login, and the user kind of don't know how to secure it.
Yeah.
Don't even care.
You're saying TPM, is that what you said? Typical. Oh, yeah. So, yeah, agreed. I mean, the identity model inside of the ESX host, honestly, is not the best. So with 6.7, they're doing a little bit of better job of advancing that. But high trust is typically what customers go to all the time when they say, look, I want to create a better, secure, privileged identity management system for the host. We always recommend customers use high trust.
Thank you.
No problem. Any other questions? All right, I appreciate you having me.
With that, guys, we'll be at Drought 55. It's at 245 East 55th Street. You have to have your BlackRock badge in order to have any libations. But again, thanks Chris, TrapX, Komodo. Thank you, Tom, for inviting OWASP. It's always a pleasure. See you soon. And remember, we have Hack NYC Submit your papers for critical infrastructure, hacknyc.com. Thank you.
No, that's Evans.
Guys, please grab your garbage and try to throw it out so mommy doesn't work here.
It's okay. We've all taken care of.
Oh, thank you, Mike, for hosting. The event as well.
Thank you. You mentioned Nsx is not as needed.
My wife even told us about the Thanksgiving Day sale.